Okay. Uh, Greetings to all. Today we will start with the session. Last session we discussed about hashed list search. So what is hashed list search means? Uh, in the hashed list search, we can able to find the target value with one comparison or one or two comparisons. In hashed list, the keys used to search a particular data item. Okay, the keys will be directly converted to address using some hash functions. But what is the disadvantage of this concept means there is a chance of collisions. So when more than one keys generates same address, in such case, it is not possible to store more than one item in the same address. So we will find alternate location to store the second data item. For that, the collision resolution techniques are used. There are different collision resolution techniques available that we discussed in our last class. At the end of this session, we will see one simple example for a hashed list search. Okay, and we discussed about introduction to sorting techniques. So sorting technique is very important problem. Okay, so in most of our life, we will in our lifetimes, sorry, real life scenarios, we will apply the sorting techniques in many places. So sorting techniques, there are different sorting techniques available in computer. Sorry, generally, okay. But we are going to discuss about only two sorting techniques: bubble sort and a selection sort. So in today's session, we will see bubble sort, selection sort, and also example program for these problems. And after that, we will discuss one example program for the hash search problem. Okay, and so sorting is the process through which data are arranged according to their values. It may be ascending order or descending order. Okay, so we can sort integer, numerical data, string data, or objects. Objects means based on one attribute we can sort it. Suppose if we are taking a student, so student is an object. Suppose if we assume that roll number, name, age, CGPA, these four are the attributes of the student object means we can sort it either using the roll number or using the name or using the CGPA, either ascending or descending. So these are the possible sorting options. We can apply any ascending order or descending order, no problem. So normally by default sorting means it is ascending order. Okay, and sorting techniques are generally classified as internal or external sortings. Internal sorting means all the data, whatever the data we are going to use, we are planning to sort, all the data will be moved to memory and the sorting operations will be performed. Okay. But external sorting means suppose if we have large amount of data, it is not at all possible to move all the data into main memory at the same time. In such case, we will go for external sorting. So in external sorting, the data from hard disk or the secondary memory will be moved to main memory part by part, and then sorting techniques will be applied. So this is an external sort. Okay, and these are all the chart which represent the different sorting algorithms. In this, we are going to study about only bubble sort and selection sort. Only two sorting algorithms we are going to study. In your later semesters, you are having design and analysis of algorithm course. In that course, you will study the rest of the sorting algorithms. And in sorting techniques, there are some basic terminology that we need to understand. The first one is sort order. So what is sort order means? Whether the order of sorting, it is a ascending order or descending order. The values stored from small to large or large to small. So that is what sorting order. Okay. So the normally in most of the cases by default sorting means it is ascending order. Okay, example, rank 1 to 100. Okay, or age of students from smaller to highest. Okay, so like that. But in some cases the default also from large to means a larger value to smaller values. Okay, so if you are taking batting average, so batting average of players means mostly the top batting average will be displayed first data and after that second data. So based on type of data we are processing, the default sorting order, okay, so will be applied. Okay, by default mostly sorting order means it represents ascending order. The next one is sort stability. What is sort stability means? Suppose if the data, whatever the data we are having, in that the key value, if it is a duplicate or more than one key values are same values, then in whatever the input data we are giving, in the same order the output data also, the data arranged or it is changed. Okay, so that is what sort stability. If it is not changed, it is a stable, otherwise it is not stable. Okay, here in the given example, if you are checking 212, the key value appears in three places. Okay, in the B, the 212, in the input data, green appears first, yellow appears second, and blue appears third. In the second is sorted data, it is a stable sort. Okay, why we are calling it as a stable sort means, see, in the input order, the data with the same key, how it appears, in which order it appears. Okay, the same order here also it is appearing green, yellow, blue. Input also green, yellow, blue. But in the C, the unstable sort means, if more than one data having same key, if it is rearranged in the output, okay, then the input order, then it is a unstable sort. Okay, this is second important terminology. The next is the sort efficiency. So we are studying data structures, and whatever the algorithm we are writing, we should know the efficiency of the algorithm. So about efficiency of algorithm, we discussed in the introduction classes. So what is the efficiency of algorithm? How much time it will take to complete the sorting operation? So that is what sort efficiency. Mostly it will be estimated based on the number of comparisons, how much comparisons required to complete the sorting operation. So that is what sort efficiency in sorting techniques. And the next terminology is passes. So what is this passes means? So in comparison, one element will be means the for loop will run from first element to last element for each comparison. Okay, if for loop completes one loop means that is one pass. Okay, like that we need to execute minimum n into n passes, then only the sorting operation will be completed. So completing of a one complete comparisons is one pass. During the sorting process, the data are traversed many times for comparison purpose. So each traversal is called as one pass. Okay, now let us start with the first sorting technique. So first sorting, what we are going to discuss is the selection sort. So what is in selection sort, what we will do means, suppose if we have array of values, in the array of values it will be basically divided into two halves. The first half is sorted and the second half is unsorted. Initially in the sorted part there will not be any element because the entire array is unsorted. After each pass, first we will compare all the array. In the array, entire array, whatever the smallest element, that smallest element we will take and swap with the first element. Okay, now the first element contains the smallest value. Now we will start performing the comparison operation from the second element onwards. From second to last element, whatever the next smallest value available, that we will select and then exchange with the second element. We will repeat it for all the n values. So this is what selection sort. It means that we are selecting the smallest value in each pass. After that, we are moving it to the front, means the sorted part. So for each iteration, for each pass, the sorted part of the array will grow and unsorted part of the array will shrink. At the last, the entire array will be in sorted format. So this is what selection sort. Let us take this example. Here in the original list, we have 23, 78, 45, 8, 32, 56. If you are taking these values, the entire array is unsorted. There is no, here the array is not divided into two parts, that is a sorted, unsorted. Initially, the array will be in unsorted fully, our entire array is unsorted. Now, first what we need to do means, we need to find the smallest value in this array. So we are checking 23, no it is not. 78, no it is not. 45, no. 8, yes 8 is smallest. And then 32, 56, the smallest value in the entire array is 8. Now 8 and 23 we are exchanging. See here, now 8 is moved to the first index, and in first index, whatever the value available, 23. 23 is moved to the place of 8. Now, the first element is sorted and the rest of the array is unsorted. Now, in the second pass, again, we are trying to find the second smallest value, 78, 45, 23, 32, and 56. So, 23 is the smallest. Now, 23 we are taking and exchanging with the 78. See here, 23 and 78. Now, the sorted array contains two values and unsorted part of the array contains four elements. So in this way, if we need to repeat it for the entire array. So at the end, after pass 5, the entire array will be in sorted format. Okay, so this is what selection sort. See here, in selection part, what we are doing in the entire array, for each iteration, we are finding the smallest value and moving it to the front of the array, means the sorted part of the array. So this we are repeating for the entire array. This is what selection sort. Now see here, this is the algorithm. For the algorithm, we are passing the list of array and the last element, index of the last element. Algorithm selection sort list. It contains the unsorted data and the last index of the last element. Okay, and after execution of this algorithm, the list contains sorted value. Okay, and here setting the current value to 0. Okay, and performing the iteration until, so we need to perform 0 to last. Okay, so all the elements we need to perform the sorting. Okay, first loop ensures that we are repeating the process n times, and inner loop, in inner loop only we are checking the comparisons. So setting the smallest to current, we are assuming that the first value is smallest initially, because if you want to find the smallest element in the array, we need to compare each element with one element. Okay, so that element we are assuming that the first element is the smallest element, like that we are assuming, and then from the second element onwards we need to start searching. Okay, so setting the walker to current plus 1 and iteration if the walker is less than last. Okay, if the walker data is until the walker is less than last. Okay, until the walker reaches the last element. If walker data is less than the smallest data, then smallest is the walker. Okay, and incrementing the walker. Okay, so in this way we are trying to solve the selection sort algorithm. The same algorithm is converted into program in the next slide. See here, selection sort. Okay, integer current equal to 0, walker equal to 0, smallest, and the first while loop, current is less than last, and the inner while loop, while walker less than or equal to last. We are comparing list of walker is less than list of smallest. Okay, so this example program I'll share it in the classroom. The execution we will see at the end. First we will complete the theory part. Okay, so the next sorting technique, it is called as a bubble sort. So what is bubble sort means? In the selection sort, we traverse the entire list and then we identify the smallest and we perform the exchange operation. In bubble sort, the adjacent numbers will be compared. Means jth element and j plus 1th element. If j is less than j plus 1, j is greater than j plus 1, perform the swap. Again, repeat this step. Okay, the adjacent element will be compared and we will perform the swapping operation. The rest of the thing is same. Here also in the entire array we will have sorted part and unsorted part. Okay, so for each pass, sorted part of the array will grow and unsorted part of the array will shrink. Okay, at the end the entire array will be in sorted array. It contains the sorted data. Okay, so this is what bubble sort. Let's take this example. See here, in this initially the entire array is unsorted. So as I said, first we will compare the sorting operation. We need to bring the smallest value to the front. Okay, at the end of the first pass. Okay, so first 32 and 56 will be compared. Okay, so when you are comparing 32 and 56, 32 is smaller, so 56 and 32 will be swapped. After that, here 32 will be there, 32 and 8 will be swapped. Okay, no need to change 32 and 8, and 8 and 45 will be compared. So 8 will come to this location and 45 will go here. And again 8 and 78 will be compared. 78 will go to this location and 8 will come to the index 1. And then 8 and 23 will be compared. Okay. At the end of the first pass, 8 will come to the beginning and rest of the elements will be 23, 78, 45, 32 and 56. Okay. So now the sorted part contains 8 and the unsorted part contains the remaining 5 elements. The same way we need to repeat the process. Now compare the 56, 56 and then 32. 56 and 32 if you are comparing means it is in sorted order, no need to change it. Now 32 and 45 compare. So 32 will come to this location and 45 go to the next location, values changed. And then 32 and 78 change. 32 and 23 no change. So 23 is in the sorted part. So 8 and 23 in sorted part and the remaining values in the unsorted part. So this is what bubble sort technique. So in selection sort, we are traversing the entire list and finding the smallest. And in bubble sort, we are comparing the adjacent values and bringing the smallest to the front. Okay, the same we can perform and moving the largest to the end, either bringing the smallest to the front or moving the largest to end. By changing small correction, we can implement both. Both are bubble sort only. Okay, either bringing the smallest to front or moving the largest to the end. So this is bubble sort technique. And for that also algorithm given here. So current value to 0, sorted to false. Okay, so here until all the elements are sorted, we need to repeat Walker data less than Walker data Walker minus 1 adjacent values. This is what I said. Walker is compared with Walker minus 1. Okay, if it is so, we are performing the exchange operation. Okay, now for that also example program given here. Let us see the example program in the window. Okay, just I'll share the desktop. Wait. Now, I hope my desktop is visible to you. Yes.
Yes,
Yes,
sir.
sir.
Okay. Now the bubble sort program. Okay, so this is our first program, bubble sort. So this program, the function bubble sort function, it is implemented as it is given in your book. Okay, so the same algorithm we converted to program. Okay, so the first we have current location and then whether sorted is true or false. Okay, sorted 0 means false and 1 means true. Then last element of the last index of the array size minus 1 walker equal to 0. Initially walker is 0 and temp is for performing the swapping operation. Okay, now while current is less than last and sorted equal to 0, walker equal to last and sorted equal to 1. Now while walker is greater than current. Okay, then we are comparing the walker with the next element. Okay, this is bubble sort. Okay, the next element and sorted equal to 0. Suppose if we need to perform the change means we are performing the exchanging. Okay, swapping of the values temp to walker and walker equal to walker minus 1 and walker minus 1 equal to temp, reducing the walker and current value we are incrementing. So this is the main function. From here I am calling the bubble sort and then printing the result. Okay, let us check this program. See here, this is input array and then output array is sorted. Okay, what we can do means we can call the display function here for each pass. What is the output? Like that we can check it. Display function, and right here I'll write the display function. I already have display function in some other program that I am copy pasting. Now, here in each pass, how it is happening, we can understand. See here, unsorted list is 44, 22, 66, 55, 88, 77, 99, 11, 33, and 1. So in this, the smallest value is 1. So in the sorted list, in the first pass, if you are taking, the 1 is moved forward to the first location. Okay, and in the second pass after that the next smallest value is 11. 11 is moved to the second location, and after that 22nd is moved to the third location. So in each pass the smallest value is moved forward to the beginning of the list. Okay, suppose if you wish to understand in each pass how the swapping is happening, in such case what we can do means we can call the display function in the internal loop. Okay, we can keep the display function in the internal while loop. Okay, now let us compile. See here, now this is the input value. Now see here, 33 and 1 it is compared and 1 is moved here. Okay, after that 1 and 11 compared and 1 is moved here. Next 1 and 99 is compared and 1 is moved forward. So in each step of the for loop, okay, the 1 is moved to the beginning of the array. So the beginning of the array contains the sorted list, and after that we have unsorted list. So the smallest value, okay, by comparing the adjacent values, the smallest value is moved forward to the beginning of the list. So this is what the bubble sort program, okay, bubble sort algorithm and program. Okay, suppose if you are searching the net, you will find some simple programs also. The concept is, what is the concept? Comparing the adjacent values and finding the smallest. Okay, starts from 0 to n. It ensures that we are comparing all the n values. And the second inner loop, it starts from n minus 1. N minus 1 means the last element, okay, and greater than 0 till the first element. What we are comparing means the jth element. Okay, the last element is compared with the j minus 1. It's a previous element. We are comparing two elements. Suppose if the j, okay, the last element is smaller than the j minus 1th element, we are performing the comparison. Okay, and we are repeating this process for all the n values. Okay, so for this also the same output we will get it. First I'm commenting this display function. Okay, see here the output is same, bubble sort. Okay, if you are checking the stepwise output, it will be same as the previous algorithm. See here. Now this is the input array, and here in the first pass we are comparing 33 and 1. Okay, 33 and 1. Since 1 is smaller than 33, 1 is moved to the previous location, and 1 and 11 compared and 1 moved forward. and 1 and 99 compared, one is moved forward, and 1 and 77, one is moved forward. Okay, so like this, the smallest value 1 is moved to the beginning of the array. Okay, so this is bubble sort. As I already told you, in bubble sort, we are performing the comparison of adjacent values. Okay, now let us move to the selection sort. So selection sort, this is the algorithm I have given in the PPT. So the same algorithm given in the text, it is converted into C program. Okay, so here, as I already told you, we are trying to find the smallest value in the array. If then at the end, once we found it, then we are exchanging with the first element of the array. Then from the second element onward to last element, the next smallest value we are trying to find, and that smallest value is exchanged with the second element. Okay, so this is the program. Let us check the output. See here, this is input and this is output of the program. Okay, suppose if you wish to see the stepwise output, so here I have the display function. We can call this display function in the loop. Okay, now display of list comma size. See here, in the entire list, 1 is the smallest value, and after identifying 1 and 44 is swapped. So 44 is coming to the last value, and 1 is moved to the second. Then in the remaining list, the smallest value is 11. 11 is moved to the second location, and 22 is moved to the place of 11th. Okay, we are in each pass, we are trying to identify the smallest value, and the smallest value is exchanged with the first element, second element, third element, fourth element, and so on. So this is what the selection sort. Okay, so in the selection sort algorithm, so this program, we converted the given algorithm, whatever the algorithm given in the text, the same we converted into C program. Okay, the outer loop, it ensures that we are performing the comparison operation for all the n values, and the inner loop, what it is performing is it is finding the smallest value. Once the smallest value is found, then we are performing the exchange operation. Okay, the smallest value is moved to the first, and the first value is moved to the smallest. Okay, so this is what we are doing in this program. The same, the simplest form. Okay, see here, using the for loop I and j. Okay, see here, I equals 0, I less than size, I plus plus. The outer for loop ensures that we are performing the comparison for all the n values, and the inner for loop, it is to find the smallest value. You can compare this program and this program, how it is working. Okay, now let us run this program. See here, the same output. Okay, suppose if you wish to check the stepwise output of this program. Okay, then we can call the display function after the means in the inner for loop. Now let us check it. The size output of both the programs will be same. See here, this is the input unsorted list. The first element is 44. In the entire list, the smallest value is 11. Sorry, 1. 1 is at the end of the list. Now, after the first pass, 1 is moved to the beginning, and 44 is moved to the place of 1. Then no need to uh, compare the 1 because it is the smallest value. So we need to perform the searching from the next, means second element to last element. So in this list, the smallest is 11. So 11 will be moved to the second location, and in second location 22 is available, that is moved to the place of 11. Next, in the remaining values, the smallest value is 22. So 22 is, sorry, 22 will be moved to the place of 66, and 66 is going to the place of 22. Okay, so this is what selection sort. Okay, from the entire list we are finding the smallest values and we are bringing it to the beginning of the array or beginning of the list. Okay, so this is selection sort example. Okay, now uh, we will see example program for the hash search. Okay, so as we already discussed, in hash functions, okay, in hash search, the key values will be converted into address by using some hash function. Okay, the hash function you can use any. There are different hash functions available, so that any function you can use. So in this example program, I have used simple mod operation. See here, this is my insert function. Okay, I have one array. In that array I am going to store this value. Okay, and this is the size of the array. And what, how I am calculating index? In array, address is the index. So how I am calculating in which index I need to store this value means index equal to value mod size. So simple modulo operation I am using to store the uh, to store the value in the uh, a particular index value. Okay, so after finding this one, okay, I am ensuring that that place is not it is free. I am ensuring that the particular index position is free. If it is free, then only I can store the value in that location. If it is already occupied, it means that a collision occurred, so I need to find the next alternative location. To find the next alternative location, I am using linear probe method. What is linear probe method? Adding one with the home address. Whatever the index value I already calculated, I am adding one to that index and then applying the mod operation. Okay, why this I am doing means I have to ensure that whatever the new address or new index calculated, it must be within the range of 0 to n minus 1. So I am again applying the mod function and I am using probe. Okay, I am because I have to ensure that the finding the free space, it should not take more time or more space. So I'm limiting the number of probes. Number of probes is less than or equal to 3. So 3 probes I am taking. So while list of index not equal to 0, why I'm comparing with 0 means initially I initialized all the array elements with 0. So I am assuming that whatever the data I'm going to store in the array, its value is greater than 0. Okay. Suppose if you are taking roll numbers, roll number will not start from 0. So roll number is always greater than 0. So 1 to 100 students, roll number is 1 to 100. So initially all the array content is 0. Whenever I am entering the roll number, I am comparing, I am finding the index value for that particular roll number by applying the mod function. And if that particular array place is free, then in that place I am storing it. If it is not free, I am adding one with the index and checking the next location. And then that is also not free means I am adding one more time and then finding the next location. If it is free, I am storing it. Otherwise, again one more time I am trying. Only 3 times I am trying to find the new index values. Okay, and if list of index is not equal to 0, okay, that particular location is 0 means in that I am storing the value. Otherwise and making the success equal to 1. Initially success value is 0. So if the operation insert operation is success, I will return 1, otherwise I will return 0. Okay, now whatever the collision resolution technique I am applying here, sorry, sorry, whatever the function I am applying here to store the data. Okay, the same concept I have to use it in the search also. Okay, in the search operation also same 3 times probe I have to check, and the same mod function, the hash function also same must be used. Then only I can able to find the data. Otherwise it is not possible to find the data. Okay, now in main function I am using the do while loop and then switch. Okay, for each case inserting the value, displaying it and printing the entire list value. Okay, and perform the search operation. Okay, now let us compile this program. Okay, see here, These are all the options: insert, display, search, and exit. Totally 10 elements I can store. So first I'm inserting all the 10 values. Okay, choice 1, 55, choice 1, 44, choice 1, 77. Now if you are taking 55, 44, 77, okay, please tell me in which index position these three values will be stored.
5477.
547, correct.
547.
Yeah, correct. 55 will be stored in fifth index, 44 will be stored in fourth index, and the 77 will be stored in seventh index. Now let us display it. See here, in fourth index 44, fifth index 55, and the seventh index 77. Now let us try to insert one more value which also generates the index value as a 5. Okay, I'm going to insert 75. 75 I am inserting. Now in which location it will be inserted if we are using a linear probe method?
6, sir.
Correct, because 75 its index will be generated as a 5, but in 5 already we have 55. So with 5 1 will be added, 6. 6 is available. Okay, so the 75 will be stored in 6. Okay, let us check it. 2, display it. Yes, see here 75 is placed stored in 6. Okay, now if I try to insert 24, what will happen?
8, sir.
8.
Hmm. Fail, sir. It will fail
It will fail. Why? Why?
because
Probe is
we
greater than
can
3.
probe only
Will be
3
added.
times.
Yes,
More than
But
3
up to 3 don't.
the number of probes given is a 3. Okay, because the number of probes is 3, it will perform only 3 comparisons. It will check 55, 75, and 77. Since 3 probes is over, it will give error. Okay, insertion failed. Let us check that also. Okay, now I am inserting 24. See here, sorry, something wrong. Okay, one more 24.
Sir, it is 4 probes, sir. You took it as 0
Okay,
to
0
less than or equal
to,
to 3.
okay. Let us try to insert one more value. 54. So 54, see here, insert operation failed. Okay, the number of probes I initialized to 0 and I am comparing till 3. So it's taking 4 probes. So after 4 comparisons, it will not perform any other further searches. Okay, let us fill all the values. Okay, 1, 11, 1, 12, 1, 13, and displaying 1, 29, 2, 1, 49. So all the values inserted now. Now we can perform the searching operation. So if I am searching, 11 means 3. 11. Okay, 11 is available. It found at location 1. Okay, suppose I am searching 24. See here, 24 is found at location 8. So 24 mod 10 is the 4. First it will go and in this location. Since 24 is not available here, okay, it will go to the next location. Here also 24 not available. Next location. Here also 24 not available. Next location. Here also not available. The fourth probe, it finds the value. Okay, it is available. Now, if the element which is not available in the list, let us give it and check it. And then let us give 71. Target value not found. Okay, it will check 71 mod 10 is a 1. So it will go to the first location. Here 71 is not available. Next probe it will take one more probe, one more probe. After 4 probes, still 71 is available, means it will give the reply as a 71 not found. So this is what hash search. Okay, so in this simple hash search program, what we implemented is the hash function. What we took is a simple mod function. Okay, taking the roll number of students and we are applying the mod of total number of students. Okay, then we are storing it in the respective index values. Okay, once it is done, suppose if the particular location is not available, we are applying the we are adding the one with the home address, and in that location we are storing it. Collision resolution technique, a linear probe method we are applying it. Okay, so in this is a simple example for hash search function. Okay, here instead of a simple integer array, you can use anything, string values also you can use, or you can use structures also. Okay, a structure, a student structure you can create. In student structure, roll number, name, CGPA you can use, and that roll number you can use to calculate the index value. Okay, in such case it will become a full-fledged student management system like that. Okay, inserting one student data, then searching one student data, like that. Okay, so in the entire course we are going to perform these operations only. There will be some collection of data, adding a new data, how to add it and store it, then searching, how to search the given data in the entire collection. Okay, for that how much amount of time it is going to take, and which one is efficient, which one is not efficient. Okay, so these kind of operations and these kind of analysis only we are going to do in the entire course. Okay, if you have any doubt in today's session, please post it in the chat window. And I have posted all the videos in the classroom. And regarding the assessments, mostly you will have assessment for each unit. Okay, the first means one assessment will be fully MCQ, and the second assessment will be theory content. Both will be for 20 marks. Okay. Rahul, when I entered 59, it went to 0th position. Why means we are calculating the index, okay, and performing the mod operation. So it will calculate the 9th index. Since the 9th index is not available, it is adding 1. Okay, it is adding 1 means uh, 9th index plus 1, 10. 10 mod 10. Okay, it is the remainder is 0. So it's going to the 0th position. Rahul, you under? Yeah, fine. Just 1 minute, Aditya. I wish to share one. See here. I hope this website is visible to you. Yes.
Yes, sir.
Yes. Sir.
Okay. You can Google for sorting algorithm animations like that. Okay, you will get many links. In that, I found one is a little bit a clear one. Okay, so in this, they have created algorithm means animation for most of the algorithms. Here, suppose as I already told you, if you are clicking the selection sort, okay, see here in selection sort, it is trying to find the smallest value. In the entire array, the smallest is 1. Okay, it will perform the searching till the last element. Okay, and since 1 is the smallest, 1 will be swapped with the 68. Check it. See here. Now 1 and 68 is swapped. Now the second smallest it is trying to find. Now the second smallest is 2, and again one more. 1 is available. Again already 1 is available 2 or 3 times. Okay, data is repeated. Okay. Now the 1 will be with 68. See here, swapping is over. The same way, in each iteration it will try to find the smallest value. Okay, so this will be helpful for you to understand. The same way you can check for other algorithms also. Okay, bubble sort. See here, in each iteration it is performing the adjacent values. Okay, adjacent values compared and the values are moved forward. So as I already told you, in bubble sort, either you can bring the smallest to the front or largest to the last. So in this example, they are moving the largest value to the last. So see here, 98 is moved to the last because 98 is the largest value. It is moved to the last. Yes. Okay, you can check this website. Okay, many websites are there. This one is somehow good. I'll share code. Actually, if you're comparing the sorting algorithms, mostly there are all the algorithms will run in three runtimes. Means WOF nlog n and WOF n square. Okay, actually these two will be the running time for the algorithms. In this WOF nlog n, there is quick sort. Quick sort is best sorting technique that you will study in the design analysis of course. Okay, that course and examples. If you are searching the net, means you will get quick sort algorithm code and also for other algorithms also. Okay, quick sort is the one. If no doubts, we can end the class. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.